Hello, ma'am. Hello, everyone. For our lecture 2, waves, I'm going to explain the problem set. Number 1, example 16.1. Wave on a string. A student takes a 30-meter long string and attaches one end to the wall in the P6 lab. The student then holds the free end of the rope, keeping the tension constant in the rope. The student then begins to send waves down the string by moving the end of the string up and down with a frequency of 2 Hz. The maximum displacement of the end of the string is 20 cm. The first wave hits the lab wall 6 seconds after it was created. A. What is the speed of the wave? B. What is the period of the wave? And C. What is the wavelength of the wave? So, in the given problem, based on the given, um, the first wave is 30-meter long, and the first wave hits the lava wall in 6 seconds. So the time is 6 seconds, and the frequency is 2 hertz. So in this problem, we're going to find the speed of the wave, the period of the wave, and the wavelength of the wave. So first, to find the speed of wave, we're going to solve for the velocity. So the speed of the wave can be derived by dividing the distance traveled by the time. So we know that equation from the equation is velocity is equals to um, wavelength, or the first wave, divided by the time. So the time and the first wave is given, so let's divide it. So 30 meter divided by 6 seconds is equals to 5 meter per second. Now, to solve for the period of the wave, so the period of the wave is the inverse of the frequency of the driving force. So we all know that the velocity is equals to the wavelength over time, is also equal to the wavelength times the frequency. So we're going to, by simple manipulation, just cross multiply. So it will be um, wavelength, or A, is equals to T times A times F. So um, divide both sides by AF. So we can get the formula: time is equals to 1 over the frequency. So let's just substitute the value. So um, time is equals to 1 divided by the frequency is equal to 2 seconds raised to negative 1. So the period of the wave is equals to 0.50 seconds. And now, the wavelength can be found from the speed and the period. So since we already obtained the value of the speed of the wave and the time, so we can solve for the wavelength. So wavelength is equals to velocity times the time. So velocity is equals to 5 meter per second times the time, which is 0.50 seconds. So the answer would be 2.50 meter. So 2.50 meter, cancel ra ang seconds. Problem set number 2, example 16.2. Characteristics of the wave. So taas man gud ni siya, so di na og basahan ang problem. But in the given problem, the given are the first is the figure 16.6, and the time 0 seconds as dotted line, and the wave at time 3 seconds as a solid line. So in this problem, we're going to first determine the wave and the amplitude, and next we're going to find the propagation velocity of the wave, and lastly we're going to calculate the period and the frequency of the wave. First, so we're going to determine um, the wavelength and the amplitude. So by reading the wavelength from the graph, looking at the purple arrow in figure 16.7, so read the amplitude by looking at the green arrow. So the wavelength would you can see the wavelength in at the purple arrow, while the amplitude is by looking at the green arrow. So the wavelength is equals to 8 centimeter and the amplitude is equals to 6 centimeter. Next, we're going to solve for the propagation velocity of the wave. So the distance the wave traveled from time 0 seconds to time 3 seconds can be seen in the graph. Consider the red arrow, which shows the distance the crest has moved in 3 seconds. So the distance is equals to 8 centimeter minus 2 centimeter is equals to 6 centimeter. So the velocity is equals to the change of distance or the of position divided by the change of time. So 8 centimeter minus 2 centimeter divided by 3 seconds minus 0 seconds would be equal to 2 centimeter per second. And now we're going to solve for the period and the frequency. So first, the period. So time is equals to the wavelength divided by the velocity. So the wavelength is equals, so based on the answer in the letter A, so wavelength is equals to 8 cm, and the velocity is equals to, based on the answer in the letter B, so velocity is equals to 2 cm per second. So the answer would be 4 seconds since the centimeters would be cancelled. And lastly, for the frequency, same process lang sa pag-derive sa formula from the previous example. So from um, from wavelength divided by t is equals to wavelength times the frequency, cross multiply, then divide both side lang by t and wavelength. So the final formula would be frequency is equals to 1 over the time. So time is equals to 4 seconds. So 1 divided by 4 seconds is equals to 0.25 hertz.